This is Algebra 1, Semester 2. This is the unit Quadratics, which is the third unit. And this lesson is called Vertex of a Parabola Practice. It's lesson number 16. It's on creatormath.com under the Algebra 1 tab. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So just to continue to model for you where those notes are, because students are just saying to me, where are those notes? Make sure you're on creatormath.weebly.com. You may have to put that in when you search it on Google to find it. Run to the Algebra tab. And if you want to see the Home tab, I always kind of go back here so you know you're in the right place. Then the Algebra 1. Pass by the vocabulary stuff, which you need for your vocabulary assignments. Go to the table of contents, which you've already copied onto your pages 2 through 6, by the way. You have a copy of this if you did what you were assigned to do. Here's a unit exponents. Here's a unit modeling 2 variable data. Here's a unit quadratics, and we're all the way down on lesson 16. So follow these numbers. Here's 16, vertex of a parabola. Here are the page numbers. Go look it up on the original table of contents now, because by the time you watch this video, it's probably going to be different. Here's notes, problems, and the video solution will be tagged right here, by the way. The link will be put up. So let's do notes. This is what you're copying into your comp book on those pages before you do the problems. This is sort of the background information you need. Mine is not loading. Sometimes you literally have to go back and do it a second time, which I do often. There we go. And so far, knock on wood, by the time I do it a second time, it does load. So they're talking to you about the x location of the vertex is negative b over 2a. We're going to use that. They're talking to you about how to identify a, b, and c in the standard form of the quadratic equation. So we're going to do that in these problems. There's some examples. They're talking to you about finding, the x value of the vertex. Once you have the x value, how to find the y value of the vertex to find the coordinate location of the vertex of a parabola or of a quadratic. To find the x location of the vertex, we use negative b over 2a, where a and b come from the standard form, a x squared plus bx plus c. There's some vocabulary here about standard form quadratic equation, about the vertex, about a coordinate location, about a parabola, spelled parabola, but pronounced parabola. Comp book, just some other notes about grading. That was from the time it was written on the board, all right? So you're copying that onto your comp book first, then you're going to these things and you're working this out. All right, so let's do the first one. The first one says, using the standard format of a, x squared plus b, x plus c, identify a, b, and c for the given function. So here's the given function. Well, they tell you that a, b, and c are the values associated in these positions of the standard form position. So a is the coefficient attached to x squared. B is the coefficient attached to x, and c is the coefficient that hangs on as the tail. Whoops, it's not a coefficient, it's a constant. Sorry about that, guys. It doesn't have a variable. You need a variable to be called a coefficient. It's just a constant hanging on. I often call it the tail, right? So here's what we got. X squared plus 6x minus 27. Just to rewrite this first one, x squared plus 6x minus 27. Is there a number in front of the x squared? Sometimes students go no, but there is. It's 1. There has to be a 1 there. Otherwise, if it's 0, this would disappear. It's not a 2 or a 3 or 4, or we would show it. So there's a 1 right there. Remember the 3 invisible 1 rule? Say you have an x here. You have a 1 in front of it, times. You have a 1 divided by it, and you have a 1 to the power. If it doesn't say any of those, that's the default values. We don't show it. We just write x. We're not going to write 1, 1, and 1. But you know there are 3 invisible 1s. It's called the 3 invisible 1 rule. And I don't know if that's official. I think I made it up. All right. But we know there's a 1 there. So a is equal to 1. B is the coefficient in front of the x and with its sign. So b is equal to positive 6. And the reason we need that is if that's a negative, it better go with it. And c is equal to negative 27. And that's all they want us to do is identify those terms a, b, and c, because we're going to use them later when we find the vertex. So I have students who go, I don't understand, where's a, b, and c, right? So start with this, and then we'll go to the other. What is a? The number in front of the x squared. Got to be 1. What is b? Negative 14. Don't include the x, right? In this setup, b is just the coefficient, not the x. The x stays here. The number comes here. What is c? 48. 1, negative 14, and 48 are a, b, and c. Do it again. A is 1, b is negative 14, c is 45. Got the hang of it? Got the hang of it yet? Right, keep trying if you don't. 1, that one's, b is 2, and c is negative 63. Always carry the sign with it. So if it's a negative, carry that negative with it. All right, again, one more time. A is 1, B is 22, and C is 121. 6. Given the following quadratic, find the x location of the vertex using x equals negative b over 2a. And I kind of wish I had done this with capitals. X equals negative b over 2a, because I had to identify a, b, and c using capitals, so I wish I'd put that into this one. And maybe if I go back and think about it enough, I'll redo it. All right. And the y location of the vertex, plugging the found x value back into the function. What is the proper setup? Hint. Graph the functions on desmos.com. So always remember this. You are using technology to your advantage. You have it at your fingertips. There we go. Let's get rid of this. I can go straight and just graph this. I already have it plugged in. X squared plus 6x minus 27. Now, I want to know where the vertex is. Just click on this thing, and it'll tell me, you guys. Click again. There we go. I know the vertex already. It's negative 3, negative 36. Right? Ding! Yeah. You don't have to do any math to do this, to get this problem right. All right? And that's the point. The point is that you're supposed to use technology to help you. Now, can we calculate it too? Well, let's go back and do the longer route. I don't have much room here. A is equal to 1, B is equal to 6, and C is equal to negative 27. I only need A and B because the x value here, x equals negative b over 2a, which equals negative b, so it's a 6, so it's negative 6, over 2 times a, which is 1. 2 times 1 is 2, which is negative 3. Negative 6 divided by 2 is negative 3. That's the x location. Now we take this and plug it back in to find the y. You're going to like Desmos a lot better after this procedure, huh? So let's change it out of the function notation to y equals x squared plus 6x minus 27. That's the original. We now know what x is. Y equals, and we now know what, negative 3. Use a parentheses to square it, plus 6 times negative 3, because 6x minus 27. So y equals negative 3 times negative 3 is 9. A negative 3 times 6 is minus 18. And a minus 27. Y equals. And I'm probably going to be just like you. I'm going to get really lazy, and I'm not going to write all these out. I can do these so quickly a different way, right? So if I can do it a different way, let's see if I can. I could graph them all. I might graph them all. What are we doing? We're doing 9 minus 18 minus 27. Negative 36. Sure enough, x is negative 3, and y is negative 36. Okay? That's what they're asking us to do on each of these. They're also telling us to graph, so I could do that and just check what the whole thing is. Here's what they're giving me. I've got negative b over 2a. Let's just find the x value. How about that? X equals negative b over 2a. Let's do that. Yeah, and I should update all these with this capitals now that I think about it. I don't really like that. Sometimes I do these things and I go back and look and just think, what was I thinking? All right, negative b. So b in this case is negative 14. So this would be a negative 14. Why is there 2? Because there's a negative in the formula for the x value of the vertex. 2 times a, what's a? 1. This becomes positive 14 all over 2, which becomes 7. I know the x value of the vertex is 7. There's no other options here. That one's out, and that one's out. I've already answered this, even without going the distance. Let's do one more. How many do they give me? They give me a bunch. They give me 12 of these. Well, I start with the original. I say y equals x squared minus 14x plus 48. Y equals, plug in the 7. 7 squared minus 14 times 7 plus 48. Y equals 49 minus, what's this? 70 plus 28 is minus 98 plus 48. 49 minus 98 plus 48. Y equals minus 1. Y equals minus 1. Okay, and that's our y value right there. Right? Be nice if I had more room to write too, huh? All right, x equals negative b over 2a, which equals negative b. That's the same, nope, different problem. Look at the 45 there, so slightly different. We do have a negative 14 over 2 times a is 2 times 1. This equals 14 over 2, which equals 7. So same x value as we had prior. Now we're going to plug in y equals x squared minus 14x plus 45. We're going to say y equals 7 squared minus 14 times 7 plus 45. So just a slightly different calculation than we did on the prior problem. It's 49 minus 98 plus, I'm just going to modify this to 45, and I'm going to say this, y equals minus 4. Check, right there. And all my answers come up A, but for you guys, your answers will be randomized. X equals negative b over 2a, which equals negative b is a negative 2 right here, so negative 2 over 2a, which is 1, over 2 equals negative 1. Check. Y equals x squared plus 2x minus 63. Y equals, we said negative 1 for x, square it, plus 2 times negative 1, minus 63. So that's going to give us a 1 minus 2. 1 minus 2. Negative 1 squares to positive 1. 2 times negative 1 is minus 2. Minus 63. Is y equal to minus 64? Check. And so it's this one, which I knew it was already, but I did the work. 1, 2, 3 more. Look at me, I'm getting tired already. Okay, so x equals negative b over 2a. Negative b, it's a 22 here, so negative 22 over 2 times 1, negative 11. Check. Y equals x squared plus 22x plus 121. Y equals negative 11 squared plus 22 times negative 11 plus 121. And remember, as long as I write this correctly with parentheses, maybe I even get so lazy that I go parentheses negative 11 parentheses, oh, I need to turn my calculator sideways because I want to square it, right? So it's negative 11 squared plus 22 times negative 11. There we go. Plus 121. Don't like that one bit. So what did I type in wrong? I have negative 11 squared. I don't like this parentheses here at all. Clean up my parentheses. Negative 11 squared plus 22 times negative 11 plus 121. I like that better, and it's 0. Check. So y equals 0. And number 11, x equals negative b over 2a, which equals negative 22 over 2, because a is 1. Negative negative is positive. That's a positive 11. So y equals positive 11 squared minus 22 times 11 plus 121. And I'm not even writing out much. It's the same problem, just with a sign change. And so I've got, let's get rid of this. Negative 11, it's not going to matter, but let's get rid of it. 11 squared minus, why do I have a minus there? Oh, because it's in the problem here. Minus a positive 11 plus 121. Ha! Y equals 0 again. I love that. That's cool. So we had x equal to 11 and y equal to 0. One more. X equals negative b over 2a, which equals negative. There's no b here. B is 0. Look at that. There is no b. There is no middle term. So just to write this out so you can see it a little bit clearer, f of x is equal to x squared minus 121. There is no coefficient times x. It's 0. So if b is 0 here, it's going to be negative 0, right? Once you have a 0 up here, this whole thing equals 0. So my x value should be 0. Check. Once my x value is 0, let's plug it in here. Y equals 0 squared minus 121. It's got to be y equals to minus 121. That's kind of cool. So there it is right there. Make sure you are matching up this lesson name and its unit, etc. It's Algebra 1, it's Semester 2. The unit is Quadratics. The lesson is number 16. It's called Vertex of a Parabola. Practice on creatormath.com under the Geometry tab. Under the Algebra tab, sorry. And I hope this helps.